today I would like to tell you regarding the heavy metal stress in the agriculture crops and its mitigation. If you see in general, then farmers, they are most acquainted with the stress like drought, waterlogging, salinity, freezing and chilling injury, but he is not well acquainted about the heavy metal stress, especially in the agriculture crops. If you see, they will impart very much influence on the yield and productivity, especially in terms of the quality. But even though this part is now right now ignored by the farmers. So it's my privilege to say something about the heavy metal stress, their possible impact, their mitigation. Okay, knowingly and unknowingly, our crops, they has been affected by the heavy metals. So, what's the heavy metal first? So I have right now, just so am I audible, dear all? Is confirmed?
Yes, sir, audible, sir.
Yes, so I have divided my, whole the content into different sections. Like first thing I would like to tell you regarding some introduction part. My introduction will include regarding the heavy metals, their possible toxicity, and what are the sources, different sources, and our soil and ecosystem and our food system, how they're going to are contaminated by this type of the metals. I will tell you in the introduction part. And what are the possible mitigations? So I will tell you, we have different type of the mitigation strategy. It may be the chemical, it may be the physical, but all are the very, cost effective and I think not appropriate. So it would be better if you go for the phytoremediation part. And I will tell you what are the, advantages and disadvantages, because phytoremediation, this is not an easy task. It will take a lot of time. And especially the selection of the plants, its cultivations for the purpose of the mitigation is not an easy task. So I will tell you. Now, I will tell you different type of the mechanism, which are, the key factor behind all type of activities. If you go for mitigations, I will tell you different type of the classifications and process. Now, I will tell you the examples of the phytoremediation, what are the type of the plants we can utilize for the mitigation purpose. It may be our cultivated crops, it may be our edible crops, it may not be our edible, it may be some other thing else. Okay? And finally, conclusion. Stress is the major concern right now. And, stress is increasing in terms of the abiotic stress, in terms of the biotic stress. Abiotic means those are which are directly connected with the climate changes. Okay, as I told in our just few minutes before, like drought, mitigation, and waterlogging, salinity. These all are the major concern right now. But besides these things, we have something more like heavy metals. Okay, so I would like to tell you this heavy metal. We have metals, D block element metals, and if the density is more than 3 to 7 grams centimeter cube, then this is called as heavy metal. If you are following the range of the density 3 to 7 gram per centimeter cube of any metals, then this is called as heavy metals. Within the heavy metals, if you see, then we have two parts. One part is the beneficial and one part is not beneficial at all. Okay. If it is beneficial up to a certain range, so, then this is called as the...
This is Diptanu Banik sir from Jalandhar.
Yes, Diptanu.
Yeah. Hello. So, good evening to everyone. So my question is, I am an agriculture specialist. I am an agronomist. So,
yes. Hello, Diptanu. Diptanu, you are not audible, dear.
He's on call, sir.
Okay.
No, sir, he's on call. Actually, he's speaking on phone.
Okay, may I continue, Rohit?
Yes, sir. Yes, sir.
Hello, Rohit.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
How?
Continue, sir. And sorry for interruption, sir.
No problem. So, so again, come back. The definition of the heavy metals means, suppose if you have metal and their ranges are density range, mass per unit volume. If that is ranging from 3 to 7 gram per centimeter cube, then this is called as heavy metal. Okay, and within the heavy metal, you will see we have two ranges. One is the essential, one is the not essential at all. If it is essential, then definitely we have the microelements. But within the microelements, again, we have some limited range. We have certain range. And if you go beyond that range, then definitely it becomes toxic for the plants. But we have certain metals which are not essential at all. Like I would like to tell you the name of some elements like cadmium, lead, arsenic. Arsenic is the metalloids. Okay, and likewise, so these are not essential at all. But in our agriculture system, you will see in the soil we have little bit more critical values of these elements beyond the limit. So it may come inside our ecosystem and ultimately in the food system and finally comes into our body and all. So my purpose is this type of the metal should be removed at least from the agriculture farm. Suppose I would like to tell you in the case of the cadmium. Cadmium mostly comes from the phosphatic fertilizers because the phosphatic fertilizer their sources are the rocks. The phosphatic fertilizer their sources are the rocks, and almost all the fertilizer company they claim okay, their fertilizers are now filtered from cadmium toxicity and all. But till date, if you utilize the very huge amount of the phosphatic fertilizer, then knowingly and unknowingly you will see within the soil system we have more amount of the cadmium, and this cadmium leads to serious hazard in the plants as well as through the plants it will come in our system. Okay, and there is one popular disease. This disease is called as the Ita disease. Okay, and this disease is caused by the cadmium toxicity in our body. And personally, I have visited the many places in the West Bengal. Okay, and especially the sewage treatment plants. Like I would like to tell you the name of some places like Bhatpara, Navadi, Chandan Nagar, okay, Sundarpur, and Tatla, Nadia. These are the places near the West Bengal. I have visited many times. And the purpose was to investigate the heavy metal toxicity in the concerned farm. So I have seen the farmers, they have utilized a lot of sewage treatment, water, okay, in their farms. So I know because of this sewage treatment waters are a very good source of the nitrogen because of the presence of the organic material. But at the same time, they have the very high amount of toxic metals. So a lot of the vegetables have been grown at that places, and you will see these metals are now coming into the root zones and finally into the plant bodies. So I have seen personally this type of activities in the farmers near the West Bengal. So this metal toxicity is the major concern, right? Okay, ultimately it will influence the quality of the crops. So you may call it as the pollutant as well. And so we have different type of strategy to reduce such type of the pollutant in our farm. So one method to reduce the pollution is like you have to treat the soil. Okay, treat the soil. It may be the thermal treatments, it may be the acid leaching, it may be the electro reclamation and all. But I am damn sure if this is not the too easy task. It is very full of cost and all. Okay, and if we have some other treatments like if you go for the water treatment involved, then sedimentation and thermal treatments with the mechanical filtration, these all are the methods. But again, I would like to tell you practically that these all are not the feasible methods sometime. So why not we can go for the phytoremediation because this is very effective process. And phyto means plant and remediation means mitigation and removal. Okay, so with the help of the plants, if you try to remove the metals from contaminated site, then this is called as the phytoremediation. And you will see these are not too much costly. Okay, and these phytoremediation strategy is the friendly approach in terms of the soil health, or in terms of the environment as well. But yes, we have limitation of the times because it will take some time longer. Very long period is required for possible mitigation and up to the mark of the mitigation. That's why. So phytoremediation, this is technology developed by the developed by some scientists, and we can utilize some engineered plants so that they can scavenge the maximum metals from the contaminated site without affecting itself, and they can remediate the possible soil with the help of the other mechanisms. So phytoremediation is a very good approach. So need of the phytoremediation is very important. First of all, their need is very much concern. Why? Because this is a very low cost effective technology. There is no extra cost, just like the physical and chemical method. So that's plants for the remediation purpose. Second thing, because application of this type of the plants, definitely they can improve the soil health as well as they can interact very positively with the environment. So there is no alteration of the macro and micro environment if you are placing the plant for this purpose. Okay. So I will tell you different type of examples of the plant which can be utilized for the purpose of the phytoremediation. So this is the photographs we can see here. So we can clean our earth with the help of the phytoremediation strategy. Really, this is a wonderful strategy for us. So that's why this photograph, this is a very good pictorials for such type of the concern. So as I told, so use of the green plants and their microorganisms. One thing more, if you add the microbes for the purpose of remediation along with the plants, then sometimes it may be fall under the category of bioremediation. And it is more effective. It is more effective if you add some microbes along with the plant remediation purpose. So use of the green plants and their microorganisms to reduce the environmental problems without the need of without the need to excavate the contaminants materials and dispose of it elsewhere, then this is called as the phytoremediation. So this is the natural process, and we can remove the metals effectively. And first of all, the selection of the plant species for this purpose, this is very much important. Selection of the plant is very much important, because almost all plants, they don't have the capacity to scavenge the materials from the contaminated site. So that's why the selection of the plant, it is a major concern for us. Okay, so I will tell you different type of the classification of the plants. Some plant is called as the hyper accumulator, some plant is called as the moderate accumulator, some plant is called as no accumulator, and what type of the plants we can select for our remediation purpose. So selection of the plant, this is the very much important concern for us. So here we have some example. And here we are some advantages and disadvantages of the phytoremediation. First thing, advantages is this is the in situ and ex situ process, and disadvantages is that it takes the several years, several months to remediate the contaminated site. And second thing, you can go for year by year, plantation of such crop, because one time and second time, plantation is not too much effective to remediate the 100% metals from the soil. And one thing, they can also, supply the organic and very good beneficial things into the soil, so that our soil health remain consistent for longer period. But sometimes, it is very limited to the groundwaters, shallow groundwater and soil and sediments. And here we need, this is first time slower than the conventional method. And one thing, toxicity and bioavailability of the biodegradable products, they are not known in this case. And advantages are they are very easy to implement and maintain and accept by the public. And second thing, this is the environmentally friendly approach for us. So besides this, classification, besides this type of advantages and disadvantages, we have more advantages and disadvantages. Now, what are the different type of the mechanism? We have different type of the mechanism. Plants, they can utilize different mechanism, and according to the mechanism we can select the different type of plants. First thing, you can see in a single shot we have different mechanism of the phytoremediation. First mechanism is called as phytostabilization. Now other type of the mechanism is called as the phytostimulation. Now one other type of the mechanism is called as the phytoextraction, then phytovolatilization, then phytodegradation. These all are the types of the phytoremediation. These all are the types of phytoremediation. And sometimes you will see some plants, they are very good example for the phytodegradation. Some plants are very good example for the phytoextraction. Some plants are very good for the phytovolatilization. Some plants are very good for the phytostabilization. That means not a single plant can do all the activity. We have particular plants within the particular group. I will tell you in other slides. So here you can see phytoextraction, phytostabilization, phytotransformation, phytostimulation, phytovolatilization, and rhizofiltration. These all are the methods, different type of the methods of the phytoremediation. But please remember, among all the mechanisms, we can utilize only the plants. And if possible, then please utilize the macro, and you will see their effectiveness is too high. Phytoextraction means, I would like to tell you the first process that is called the phytoextraction. It means the uptake of the contaminants by the plant roots and movement of these contaminants from the roots to the above ground part of a plant by the process of the absorption and concentrating and precipitation of the contaminants. That means here is the soil, and within the soil we have contaminants. That contaminants now absorbed by the plant roots and they can be translocated into different plant parts. Okay. Now, this process is called as the phytoextraction. And because of the movement of the metals from the soil to the plant, this soil is now away from any type of materials. So this is called as the phytoextraction. Now, second thing, we have two ways of the phytoextraction. One is the natural and one is the assisted. Natural means if plants, they have their own capacity to uptake for the materials, then this is called as the natural. So based on this natural process, we have different classification. One is called as the hyperaccumulator, one is called as the moderate accumulator. Okay, but sometimes we have assisted mechanism. Assisted mechanism means generally metals, they are not soluble in the soil. Okay, they are generally, this is heavy. That's why plant and its roots, they don't have the capacity to absorb the maximum materials. So why not we can assist these materials with the help of EDTA. Okay, we have some EDTA agents, like any type of EDTA we have to apply. And because this is the chelating agents, and because of the chelating agents, it makes availability of these metals to the root system. So that's why this is called as the assisted method. So we have different type of the EDTA. EDTA is the claw-like substances. This is the chelating materials. Okay, and sometimes plants, they can secrete the natural EDTA. Okay, so that they can absorb the metals from the respective rhizosphere. So that method is called as the assisted. Because of the presence of the EDTA, whatever the heavy metals present in the rhizosphere, it becomes soluble. Because of solubility, the root, they feel very easy to uptake of the respective metals. Now, respective metals from the soil will come into the plant. Okay, so now through this method, this soil is free from materials. So this is called as the mitigation process, and all are coming under the category of phytoextraction. This is the one of the example. So again, we have two parts. One is the advantages part of the phytoextraction, and second part is the non-advantages and what are the limitations. First thing, cost is fairly inexpensive compared to any conventional method. Second thing, to contaminant permanently removed from the soil. Okay, and amount of the waste material that must be disposed of is decreased up to the 95% through this method. And in some cases, contaminants can be recycled again. And what are the limitations part? Limitations part of this phytoextraction is metal bioavailability within the rhizosphere. Even though phytoextraction is going on, but even though we have some metals, they remain persistent in the rhizosphere of the respective crop. And proportion of the metal fixed within the roots, you will see sometime, and cellular tolerance to the toxic metal. This is our limitations. What is the limitations? Means suppose our root are not too much effective sometime, then they are unable to tolerate the metals, whatever they comes inside the plant system. So these are our limitations. So here is the need of the engineering or such type of the plants which can tolerate the metals too much, so that we can enhance the phytoextraction mechanism. So second part of this phytoremediation, or second type of the phytoremediation, is the phytostabilization. So within the phytostabilization, it means it refers to the immobilization. Potential, this is the stabilization part. Stabilization means you have to fix their movement. Okay? So it refers to the immobilization of the contaminants in the soil. And process should be either absorption or either by the accumulation by the roots and precipitations within the roots. This is called as the phytostabilize. That means in this case, you will see, in the case of the phytostabilization, you will see plant roots sometime, they may release some chemicals. Okay, and these chemicals, they can interact with the metals, and after interactions, they can stop their mobility within the rhizosphere or within the available space. So that's why this is called as the phytostabilization. But again, it depends on the amount of the materials that is secreted from the roots of the concerned plant. That is called as the phytostabilization. So purpose of this contaminant, the basic mechanism of the phytostabilization is to reduce the mobilization of the metals within the rhizosphere. If their mobilization remains stopped or slow, then their availability within the plant or other ecosystem, it should be less. And that system should be more safer with respect to where the metals are more mobile. One is the next part. The other part is called as the phytotransformation. By name, this is very clear. You are going to change their forms. Forms means with the help of the phyto means plant, with the help of the plants, or within the plants, we have large number of the phenolics, we have large number of metabolites, and with the help of the metabolites, whatever they have the form, they are going to change. And if their forms are going to change, then their behaviors, their effectiveness, their harmful and hazardousness within the plant or other ecosystem, it should be changed. That's why this is called as the phytotransformation. So also known as the phytodegradation, and it is the breakdown of contaminants taken up by the plant by the metabolic process within the plants. Whatever the contaminants they have been absorbed by the plant, it should be breakdown, or it may be attached with some compounds, natural compounds in the plant, so that we can change their forms. If their forms remain changed, then definitely it will never act just like a toxic metals. So this is called as phytotransformation. So remediation of some organic contaminants, especially if you're talking about the herbicide application, if you're talking about herbicides, and they're especially organic contaminants, we can remove by the process of phytotransformation. And sometimes petroleum contaminants, sometimes they're going to reduce by the phytotransformation process. Now, so we have advantages and disadvantages of the phytotransformation. In the case of advantages, this is very economic, and the most major concern of the advantages are it is eco-friendly. It is mostly eco-friendly. And if I'm talking about the disadvantages, then it requires more than one growing season to be efficient. There is no we need at least 2 seasons, 3 seasons, 4 seasons, so that we can efficiently remove that particular organic contaminants. So this is the one of the disadvantages. Suppose if we have limitation of the time, then we have to avoid the phytotransformation strategy for the concerned contaminants. So next one is called as the phytostimulation. Phytostimulation means rhizodegradation. This is the one of the type of the phytodegradation. This is the breakdown of the contaminants within the plant root zone and the rhizosphere. That means within the system, within the root system, and because of the presence of the microbes or other microbes, or some, whatever we have the microbial populations in the concerned rhizosphere, they may play a very important role for the transformation and degradation of the contaminants. Okay, and but an obvious that microbes, it should be interacted with the metals along with the plant roots. So plant roots and their exudates, definitely they will provide some supplements so that they can interact directly with the metals, and they can destroy, and they can remediate, they can seriously reduce their activity. That is called as the phytostimulation. Next part is called as the phytovolatilization. This is the one of the strategy of the phytovolatilization that is very clear. Phyto means plant, and volatilization means definitely something is going to convert into the vapor form. Okay, so within the plant system, you will see this is the root part, and within the root, some metals they are going to absorb, and they can process and travel through the plant system, and finally through the this leaf part, it is going to emit into the environment. So especially in the terms of the arsenic and mercury and arsenic, you can see we can remediate the arsenic and mercury with the help of the phytovolatilization. And one thing more, you can ask one question, sir, here is the arsenic, and again, because of the phytovolatilization, they are going to remit it into the environment. So what is the beneficial impact? The beneficial impact is that they are going to convert into different forms. Their forms and their activity, their effectiveness, everything is going to reduce when it passes through, within the plant systems and come out into the environment. So phytovolatilization means it involves the plant taking up some contaminants from the soil, transform into the volatile forms, and transferring them into the atmosphere. This is called the phytovolatilization. So especially in the case of the mercury and arsenic, we can do this thing. So we have advantages, the contaminants, mercuric ions, it may be transformed into less toxic substances like metal algae. And second thing is sometimes recycling by the precipitation, by rain. It may again, one of the challenges. That means suppose fertilization are going on, mercury is not available in the atmosphere, but suppose it is the time of rain. So sometime it will come back again into the rhizosphere. So this is our disadvantage in the case of the phytofertilization. But remember this elemental mercury basically removed through the phytovolatilization process. Now, this strategy is very important. That is called as the rhizofiltration. Within the rhizofiltration, rhizo means root and filtration means we are doing something with the help of the roots. So adsorption and precipitation into the plant roots. So it will take, we can take this strategy for the possible mitigation. So, but an obvious, if you want to take the advantages of the root, your roots should be very extensive. Your roots should be very fibrous and they have very good adsorption capacity. They can retain something on the surface. Then we can effectively enhance the rhizofiltration process. So rhizofiltration, you have to process your contaminants through the roots, and because we have engineered root, we have efficient root, we have a well advanced root, and they have the capacity to filter out the respective contaminants from the solutions. So that is called as the rhizofiltration. So as compared to phytoextraction, here the plants, they are more prone towards the groundwater, especially if metals they are coming from the soil to the groundwater. Then definitely at that time, rhizofiltration is very good strategy to remediate system of the metals, and we can stop the metal accumulation in the groundwater. So rhizofiltration. So again, we have advantages and disadvantages. Ability to use the both terrestrial and aquatic plant for this purpose, either in situ and ex situ. And one thing more, in the case of the rhizofiltration, the contaminants, they do not have to translocate into the soup part. This is the major concern. I would like to tell you one thing. Suppose you are using some plants which are edible, suppose that, like in the case of classification of the plant, like mustard. Mustard, we can utilize some time for the medication purpose because they are very good accumulator. Sunflower, we can utilize, okay? So like fern, we can utilize. So sometime if your plant is edible plant, then you should think about the translocation value. You should think about the bioaccumulation value. What are the amounts of the metals they can be transferred from the soil towards the root, toward the grains, toward the leaves, and like that, okay? And so if your plant is edible, otherwise there is no issue. If your plant is edible, then you have to think about their translocation, what should be the amount they are now coming into the grain part, and whether this is critical for consumption or not. If it is beyond the critical limit, then please avoid such type of the consumption. Otherwise, if your plant is woody, if your plant is foreign, if your plant is non-edible, then you can utilize, no problem. So, the basic limitation of the phytoremediation is how long does plant phytoremediation takes place, okay? So phytoremediation, they are time depending process. And if you want to know कि हमें कितना करना चाहिए phytoremediation और कितने दिनों तक करना चाहिए, it depends on your selection of the plants, okay? Type and number of the plants, what are you are going to utilize, and type and amount of the harmful chemical they are present already in the soil, and size and depth of the polluted area, and type of the soil, and the condition presents. These all are the factors which are responsible for the phytoremediation and their frequency, their strategy, their efficiency, कि हमें कितने दिन तक करें, सर कब तक करें. इसके लिए आपको सबसे पहले you have to go for the type and number of the plants you are going to utilize for this purpose. Suppose कि you are interested for the hyperaccumulator, then I think your time should be less, okay? And suppose within your soil, if elements are seriously contaminated, their amount is very high, more than the critical limit, then at that time you can go for the more time for the phytoremediation. The single time and third time is not sufficient for the complete remediation purpose, okay? And one thing more, what is your size and depth of the polluted area? Suppose that you have very big farmland, and all are all area are seriously affected by the heavy metals, then you should think about the more phytoremediation, and at least you have to go for longer year. So this is these all are the some pictorials. Yes, this is important. What are the types of the plant we can utilize? So first thing, if you go for type of the plants, especially for the phytoremediation purpose, then you should think about different factors. First factor is ability to extract or degrade the contaminants of concern. You have to choose those plants having the capacity to extract the material first. If they don't have the capacity to extract the materials, then I don't think they are very much effective for the phytoremediation purpose. Okay. So please, first of all, please go through the plant ability, whether they have the capacity to absorb absorb the elements, retain the elements, detoxify the elements or not. Then after you can go for the selection of that plant. Okay. Second thing, adaptation to the local climates. Suppose that metals is the one of the target for you. But besides this thing, you should go for their adaptations in terms of the temperature, in terms of their local micro and macro environmental conditions. If they are adopted, then you should go for the selection of that plant for the particular metals. Otherwise, it is not suitable. Now, one thing we should always care at the time of the selection of the plant, it must have the high biomass. If they have the very good biomass, then definitely their absorption capacity, their retention capacity is button up is very high. I would like to tell you one example, especially in the case of the aquatic system. There is one weed. This is called as the water hyacinth. Okay, this water hyacinth is very suitable for the observation of good very high amount of organic contaminants, especially in the water. And you will see within the 10 days or 12 days, this water hyacinth, they can almost double their biomass. So because of this, high capacity of increasing their biomass, we can utilize this water hyacinth as a very good remediator of the organic pollutants already available in the aquatic system. So this is the one of the example, high biomass. Now, deep root structure. Suppose you are interested for rhiofiltration purpose. Okay, then you should go for the deep root structure. It is good for maximum remediation purpose. Now, compatibility with the soil. Suppose that case soil and they're competitive with the plant. If it is okay, then their root they can do their work very effectively. Otherwise, not. And one thing is the growth rate. Growth rate. Generally, I would like to tell you, in the case of the growth rate, if you go for woody plants, sometimes we have some woody plants and they can be utilized for remediation purpose, but this is good. They can effectively remove the materials from the soil. But one limitation in the case of woody plant is they are very, very, very much, they can take very too long time for the remediation purpose, almost 3 years, 4 years, 5 years, sometimes 10 years, more than that. So up to that point, farmers, they can't wait. So you have to go for selection of such plant having the very less, growth period and growth rate. Now, second is of the planting and maintenance. If you are selecting the plants for this purpose, then please think about the planting and the maintenance. If the maintenance and planting is very difficult and challenging, then you should avoid such of the plant. Now, ability to take up the large quantities of the water through the roots. Suppose if you are interested for the rhiofiltration, then button obviously they must have the capacity to absorb the high amount of the water, because water is the media, one of the greatest media for entering of the metals inside the rooting system. So that's why ability to take up the large quantities of the water through the roots is the one of the major concern when you are interested for the plants and their types for the phytoremediation purpose. Now these are the types of the plant used, like you can see here, and these are my conclusions. Okay, so first of all, this phytoremediation process, it should be effective if you go for the assistance with the microbes as well. If your phytoremediation along with the microbes, if you do at the same time, then I think it will be very helpful, and the efficiency is too much high. Otherwise, you will see it will take very longer time, because microbes, they will provide some assistance sometime in terms of some chemicals, extractions and all. So first thing, and second thing, you have to go for certain type of engineering as well. You have to design at least a certain type of the plant with a very particular specific objective. Like suppose you are interested for the rhiofiltration,